I'm going to take you through these 3 easy steps which you can use to explain any motion in a straight line using the idea of resultant force. Rather than talk lots about the steps, I'm going to do examples for you. In this video I'll do the first one, and in the following videos you can see further examples. My first example is a block sliding across the table coming to a stop, and this is filmed with an overhead camera. Let's play the video again, but pause it partway through. To remind us that it was moving in this direction, I've drawn in that arrow, and I'm going to consistently call this way forwards and this way backwards. So I've labelled those to help me remember. So the first step is identifying individual forces and discussing their relative size and direction. To help with that, I've got some force names here. Now, you might think that I need to worry about weight and normal contact force, because those will be forces that are acting on the block, but they're going to be in the vertical direction and the block is moving horizontally, so I can ignore the vertical forces since they're balanced. Therefore, I just need to consider the horizontal force or forces acting on the block. And in fact, I think there's only one, which is friction. You might also say there's a little bit of air resistance and drag, but since it's in the same direction as friction, I'm going to simplify to just there being friction. So I can draw my arrow this way, indicating that there is friction acting in the backwards direction. On to step 2, which is explaining the size and direction of the resultant force. And the resultant force is just the sum, taking into account their direction, of all the forces acting on the object. And in this case, there is only friction acting in this direction, and therefore the resultant force is exactly the same as that. So let's draw that in with a blue arrow. On to step 3, to use this resultant force and any existing motion to explain what happens. I've got this little table to remind me, and in this situation, I've got it moving forwards, but the resultant force is backwards. So I've got the situation, the resultant force is in the opposite direction to existing motion, and therefore it will decelerate and get slower. Let's put that all together to make one long, nice explanation. So we start off by saying, horizontally, friction is the only force acting on the block. Therefore, the resultant force is acting in the same direction as friction, which I'm going to call backwards. But because the block is already moving forwards and the resultant force is backwards, it will decelerate and slow down and come to a stop. Hopefully you have found this 3-step structure useful to writing an explanation, and click on the end screen to watch the next video where I'll do another example.